Hello everyone, welcome to the fourth video for this series on Simulink model for electrical circuits. So in this video we are going to discuss about the unbalanced three-phase neutral current circuit or unbalanced three-phase circuit. Okay, so let's have a look at the circuit or the question here. So a three-phase unbalanced load with the following phase impedances, they are given. So basically these impedances, they are different. So for the red phase, the value of resistance is 10 ohms, inductance is 40 millihenry. For yellow phase, it is 50 ohms, inductance is 40 millihenry again. For the blue phase, the resistance is 50 ohms, and again inductance is 40 millihenry, and they are fed from a 3.3 kilovolt 50 hertz three phase supply. Okay, and we have to determine the phase current and the neutral current. So I'm going to use some of the components we have already designed in the previous circuit or in the last video. So we have already designed the three-phase star-connected AC supply and three-phase star-connected load as well. So I'm going to use both of them, and let's go on to Simulink and try to implement this unbalanced three-phase circuit. So to implement this three-phase unbalanced circuit, what I have done is I have copied the star connected supply and the star connected RL load from the previous circuit which we have designed in the previous video. So the first thing that I'm going to do is change the parameter of this all these voltage source and the load. Okay, so the RMS voltage which is given is 3.3 kilovolts. Okay, so it will be 3300 multiplied by square root of 2. Okay, so phase degree for the first voltage source should be 0 degree. Okay, so remember this is a three phase circuit, so each phase voltage should have a phase difference of 120 degree. Okay, so this one, it has a phase difference of minus 120. Supply frequency is 50 hertz, and the last one, let's change it to 3300. Okay, so that's my supply voltage or three phase supply voltage. Now for the load, again I will have to change the values of resistance and inductance. So the first load, it has a resistance of 10 ohms and 40 millihenry, so I don't need to change it. For the second load, the value of resistance is 50 ohms and 40 millihenry. Okay, and for the third load, the value is again 50 ohms resistance and 40 millihenry. Okay, so now I have changed the parameters. The next thing I would like to do is connect the current measurement. So let's look for current measurement block, and we will need three of them. So we have to measure the line currents. So let's call this as L1 or 1, this is L2 and I have L3. Okay, so let's make the connections. Okay, and this one. Right, after that I will need the value of I will need the block for RMS or true RMS. Okay, so again I will need 3 of them. So before copying I will change the fundamental frequency to 50 Hertz. Okay, and we can connect them something like that. Okay, so let's arrange it a little bit properly, and now I will need a display. Okay, to display the values. Again I'll need a number display, so let's go down to the bottom, and this is the display that we need. And again I will need 3 displays, so this is the phase current 1, 2 and 3. Okay, so I'm going to copy it and paste it. Okay, there we go. So I can now display all the 3 phase currents. Okay, now since we are in display, let's look for scope and add one of the oscilloscope as well to display the waveform. Okay, so we can add a scope maybe here, and I will need 3 inputs. Okay, so double click on it and change the number of inputs to 3. Okay, and waveform, you will need the continuous waveforms or continuous values, so connect them before the RMS block like that. Okay, so now we have a scope for measuring or displaying the waveform. Okay, right. Now in the previous case, this load uh, which we have connected, it was balanced, so there was no neutral current. Okay, but now we will have some current flowing through it, so we have to measure that current as well. We have to measure the neutral current also along with the line current. Okay, so I would need another current measurement block, so I can just copy from my diagram and I can name it as IN. Okay, or capital N. So that's my neutral current. So it will be flowing at this type of a output. Now I can rotate it to properly make the other connections, something like that. Okay. Um, the output should go into ground. So this is the ground that we will need. Okay, so let's connect the output of this current measurement block to ground. Okay. Uh, Now, of course, we'll need the RMS and the display. Okay, so let's try and copy them. Something like here. Okay, and that should display my neutral current. Okay, neutral current. Now, lastly, we'll need power GUI block. So let's drag and drop this block here. Okay, so for so now the circuit along with all the measurement we need is present. Now we need to set the stop time. So again the frequency is 50 Hertz. So let's now observe only for like one complete cycle. Okay, so let's set the stop time to 0.02 seconds or 20 milliseconds. Okay, now if we run the circuit now, let's check the output. So we are getting the phase currents to be 205.5, 64.01 and 64.01. Okay, so these are the phase current. And what about the neutral current? It's coming out to be 159.4 amperes. Okay, now another thing which we can do in the circuit is we can measure. So currently it's displaying the magnitude, neutral current. uh, this display, it is displaying the magnitude. So what we can do is we can now measure the magnitude as well as the angle, the phase angle. Okay, uh, to do that we will need a gain block. Okay, so this block we will need, and the purpose for this block will be to uh, change the peak voltage into the RMS, peak to RMS. Okay, and that we can do by multiplying whatever signal we are applying with 1 divided by square root of 2. Okay, so this thing we are going to connect it here. Okay, now after that we'll need a block called Fourier analysis. Okay, so this block, it can calculate the magnitude and the phase angle. Okay, so since we need a little space at the bottom, so let's move both of these blocks up. Okay, so I can copy a display, okay, and connect it here. So this will display the magnitude, and another display to display the angle. Right, so magnitude will be fine, but the angle which this block will calculate, it will be in radians. So we will need another, I can say, gain block to convert the angles from radian to degree. Okay, so let's copy this and paste this gain block here, and this time this gain block is converting radians to degree. Okay, and so for that we'll have to multiply the the signal which is coming in, or the values which are coming in, by 57.2598. Okay, right. Another thing which we'll have to do is we'll have to change the some settings in the Power GUI block. So we have to change it from continuous to discrete. Okay, sampling time is okay. Okay, so one mistake I have done is I have to change the fundamental frequency to 50 hertz. Okay, forgot to do that. Let's run this again. Okay, so now the magnitude is coming out to be 159.4, which is the same as which we have calculated before, and the phase angle, it is coming out to be minus 65.56 degrees. Okay, so now let's go back to the slides and quickly verify all these values using calculations. So from the slides I have done the calculation. Again, the process will be the same. So since the impedances, or the value of resistance and inductance connected in the three phase, they are different, so the value of impedance, they will be different, so we have to calculate them individually. Okay, so you can calculate XL, right, for all the three phases. The resistance values, they are also given. So using this formula, if we calculate the impedance for each of the branch, we'll get 16.06 ohms for as Z1. Z2, it will be 51.56 ohms, and Z3 will also be 51.56 ohms. So the value of impedance we have calculated, the value of voltage, it is given. So using that we can calculate the value of current. So current in the first branch, it will be 205.48. In the second, it will be 64 uh, amperes, and in the third it will be again 64 amperes. Okay, which are quite close to what we have measured in the Simulink model. Now the neutral current, it can be calculated by adding all the line currents. Okay, so if we add them together, we are getting 159 amperes, and the angle is minus 65. So we have just now added additional blocks to measure the magnitude and the angle separately. Okay, and these values are quite close to what we have measured using Simulink. So this was all that I wanted to discuss in this video. So um, in the next video we will implement we'll start about the rectifier circuit. So we'll start with half wave, full wave, and then three phase full wave rectifier. Okay, so all the three circuit we'll be discussing in the upcoming videos. Okay, so thank you very much for watching this video and hope to see you in the next.